Okay, today we are going to cover Chapter 4.2, Lesson 4.2, Angles of Triangles. The content standard, GCO 10, proving theorems about triangles, and our mathematical practices, make sense of problems and persevere in solving them, and construct viable arguments and critique the reasoning of others. Previously, you've classified triangles by their side or angle measures. And today we're going to apply the triangle angle sum theorem, and we're going to apply the exterior angle theorem. New vocabulary. This is hard to say. Auxiliary line. There we go. Got it out. Exterior angle, remote interior angles, flow proof, and a corollary. Not a coronary, a corollary. Okay, moving on. The triangle angle sum theorem gives the relationship among the interior angle measures of any triangle. And we've been talking about this since middle school. If you add the interior angles of all three, the measures of all three interior angles of a triangle, they equal 180. So the sum of the measures of the angles of a triangle is 180. The proof of the triangle angle sum theorem requires the use of an auxiliary, when you know I'd have to say that again right away, auxiliary line. It's an extra line or segment that's drawn in a figure, as you notice this one here. It's drawn in the figure to help analyze a geometric relationship. Now, as with any statement and a proof, you must justify any properties of an auxiliary line that you have drawn. Boy, that's a hard word to say. Okay, so I want you to pause for a minute and look through the theorem and see if it makes sense to you. All these should be familiar. We've used all of these before you move forward. Okay. The triangle angle sum theorem can be used to determine the measure of the third angle of a triangle when the other two angle measures are known. So because we know that the measures of all three angles are 180, then we can figure out what the measure of the missing angle is. So here's the diagram, shows the path of the softball in a drill developed by 4 players. Find the measure of each numbered angle. So they make this look more difficult than it is. If these three are equal to 180, we can just add those two together and subtract it from 180, can't we, to determine what 1 is? 1 and 2 are vertical angles, so they have the same measure. So once we find 1, we know the measure of angle 2, and then we can find the measure of angle 3 by subtracting these two added together from 180. So let's see what this looks like. So we've got measure of angle 1 plus the two measures we know. So the measure of angle 1 is 63. Well, by golly, if the measure of angle 1 is 63, so is the measure of angle 2. So now we have, for that other triangle, we have a 63 and a 79. So the measure of angle 3 would be 38. That's not hard, is it? Excellent. So then you could go back in and substitute, so you can check to see if it's correct. Now you can check your progress. So pause this video for a moment to find the measure of angle 3. Did you get C? Very good. So we can add 38 and 67, subtract it from 180. And so we get 75. That's the same measure for 2. 75 plus 48, subtracted from 80 leaves 57. Okay, that's the first part of what we're learning. Now we're going to discuss the exterior angle theorem. So in addition to its 3 interior angles, a triangle can have an exterior angle formed by one side of the triangle and the extension of an adjacent side. So what they're talking about is this right here. This side is extended on. So there, one is called an exterior angle. It's on the outside of the triangle. Each interior angle of a triangle has 2 remote interior angles that are not adjacent to the exterior angle. So see how this angle C would be adjacent, but these two, they're called remote interior because they're not next to it. They're not adjacent. They're further away. So the measure of these two added together equals the one exterior. Okay, so let's put this into practice. Now we're looking at a flow proof proving the exterior angle theorem. Now a flow proof simply uses statements that are written in boxes. And they have arrows to show the logical progression of an argument. So notice we sort of got two arguments going at the same time. Okay. We can look at this and we know 1 and 2 form a linear pair, and we're given that triangle ABC, where that ABC is a triangle. Okay. The reason justifying each statement is written below the box. So here's the reason below this statement. You can use a flow proof to prove the exterior angle theorem. So I'm going to give you just a moment to take a look. We can also use the exterior angle theorem to be used to find missing measures. So notice we sort of merge here. Okay. To me, this makes more sense. I love using flow proofs. So we're to find the measure of angle FLW. So we're looking for this measure right here. In the fenced flower garden shown. I am really having a hard time talking today, aren't I? Okay, so by the exterior angle theorem, we know that measurement of angle LOW, so this x degree, and the measurement of OWL, or this 32-degree angle, is equal to the measurement of FLW, or this quantity 2x minus 48. So we substitute in, subtract x from both sides, add 48 to both sides. So the measurement of angle FLW, since x is 80, we're going to substitute 80 in for x and then solve. Ooh, already time for you to check your understanding. So take just a moment, and I want you to pause the video, work the problem, then come back and check your answer. Did you get x is equal to 40? I set up my equation 90 plus x is equal to 3x plus 10, and then solve for x. You're going to get 80x, because you subtract 10 from both sides. 80x is equal to 2x, because I subtract x from both sides, so x is equal to 40. They're not. Find the measure of ACD. Huh, that's interesting. Measure of x is 40. If I do 30 times, or 3 times 40, 120 plus 10, I would get 130 for the measure of that angle. Isn't that interesting? Because x is just 40 is just the measurement of x. It's not the measure of ACD. So they boo-booed here. It should be D. Now, a corollary is a theorem with a proof that follows as a direct result of another theorem. So as with the theorem, a corollary can be used as a reason in a proof. The corollary shown on the screen follow directly from the triangle angle sum theorem. So this says acute angles of a right triangle are complementary. So would that be right? If they're all equal to 180 and we've got a right triangle 90, this says these two together are equal to 90. Does that make sense? Why, yes it does. Okay, here's another one. There can be at most one right or obtuse angle in a triangle. Well, because we know that two of them have to be acute, right? So only one, they could all three be acute, but only one right or one obtuse angle can be in a triangle. So when we're classifying triangles, remember, we're classifying by the third one. There's always two acute. So let's find the measure of each numbered angle. Boy, this looks convoluted, doesn't it? Why don't you pause for a moment, take a minute to draw this down yourself so you can label and see where we're going. Okay, first of all, let's look at the measure of angle 1. Well, we know that it's an exterior angle because this side keeps going, so it is equal to the sum of the remote interior angles, 48 plus 56. So it's equal to 104. And what I do when I'm working these problems, when I solve for one angle, I go ahead and I draw it, I write it out in my picture, and then over to the side I would write the measurement of angle 1 equals 104, just to keep a running tally. Now we know the measurement of angle 1 and the measurement of angle 2, they form a linear pair, so they are supplementary. so they equal 180. Well, we know what the measurement of angle 1 is, 104. So the measurement of angle 2 is 76. So now it's a good thing you have your drawing on your paper, because we're looking at the measurement of angle 3. Well, two angles form a right angle. They are complementary. So 90 minus 48, the measurement of angle 3 is 42. So now using the triangle angle sum theorem, we've got the measurement of 90 minus 34 plus the measurement of angle 2, 76. So we can find out what the measurement of angle 4 is. And it's 48. One more to go. Using the triangle angle sum theorem, we've got two of the measurements. So we add them together, subtract from 180, so the measurement of angle 5 is 49. And so if you've got a running list going, then you've got your answer ready to go already. Okay, time for you to check your progress. So pause the video for a moment and work the problem, and then come back and check your answer. Did you get 85? Well, first of all, I found the measure of angle 1 with the triangle angle sum theorem. These two subtracted from 180 give me 1, measurement of angle 1, and I got 50 for it. If this one's 50, so is 2. It's 50. So the measurement of angle 3 plus 50 equals the 135, which is an exterior angle. So the measurement of angle 3 is equal to 85. Excellent job. You are ready to move on to the assignment.